What we're going to look at today is the area, not underneath the curve, but the area in between two curves. So what we're talking about is basically the area of this shaded region here. Now, how I can figure that out is it's equivalent to the area of, the area underneath this top function in between the x-axis minus the area underneath the bottom function, or g. So if I take the green area and subtract from it the blue area, my remaining result is the area of the red area. So here's the concept that we're working with. The area between two curves is the integral from a to g of, a to b of the area of the top function minus the area of the bottom function. So let's take a look at example 1. Example 1 says find the area of the region bounded by the graphs of y equals x squared plus 2, y equals negative x equals 0, and x equals 1. Y equals x squared plus 2 is my quadratic, so it's this top function. Y equals negative x is my linear function, and x equals 0 and x equals 1 are vertical lines, so that gives us our bounds essentially. So for this example, what we're finding is the area of this blue region here. Now, how we do it is we simply take the integral from 0 to 1 of my top function, which is x squared plus 2, minus the area of, minus my bottom function, which is negative x. And we integrate with respect to x because we're adding up all of these rectangles in the x direction. Now, to do this, it's best to simplify the expression a little bit. So x squared plus 2 minus a negative x. If I take this negative sign and distribute it, that x becomes positive. So I have the integral from 0 to 1 of x squared plus x plus 2 dx. Now, we're pretty good at doing the power rule and evaluating these by hand, so now what we can do is simply type this into our calculator and get the answer. If I go to my graphing calculator, math, the ninth function, it's the integral from 0 to 1 of x squared plus x plus 2, and that gives me my answer, 2.8333. I'm going to convert that to a fraction if I can. So I'm going to use the first option, and it's not letting me, but I believe it does on a regular TI 84. Let's go back. So my area is 2.833. All right, let's look at the next example. On our next example, we want to find the area of the region bounded by the graph of f of x, which is 2 minus x squared, and g of x. So again, I know f is my quadratic, that's upside down because of the negative sign in front of the x squared, and y equals x, which is g, is my linear function. So the only thing I don't know is I don't know my intersection points. So what I can do to figure those out is I can take the expression for for f and set it equal to g. This gives me a quadratic equation to solve. So I'm going to move all the terms to the right-hand side, so my x squared term is positive, and I come up with 0 equals x squared plus x minus 2. Factoring, let's see, I have x and x. I have 1 and 2. The 2 should be positive because my middle term is positive. 1 is negative. X minus 1 will yield x equals 1, and x plus 2 would yield x equals negative 2. So I don't need to find the y coordinates because I'm integrating again with respect to x. So negative 2 and 1 will be my bounds. So it's the integral from negative 2 to 1 of my top function, which is 2 minus x squared, minus my bottom function, which is x. Cleaning this up a little bit, let's see, I get negative x squared minus x plus 2 dx, and negative x minus x plus 2. If I go to my calculator again, it's the integral from negative 2 to 1 of x squared minus x plus 2. Let's see if I have that right. Negative x squared minus x plus 2. So I'm going to go back. It's not letting me go back. There we go. Insert a negative, and my answer is 4.5. So the area between the two curves is 4.5. Let's see. Next, on example 3, the sine and cosine curve intersect infinitely many times, bounding regions of equal areas. Find the area of one of those regions. So what they're asking me to do essentially is find the area of this region or the area of this region, which are equal. So I have to do a couple things. I have to figure out which function is on the top and which one's on the bottom. And I have to find the intersection points. So let's see. My cosine function starts up at 1, and my sine function starts at the origin. So for this first region, I know that the top function is sine and the bottom function is cosine. Now to find the points of intersection, I'm going to set sine of x equal to cosine of x, and I know this happens in 2 quadrants where both functions are positive and both functions are negative and at a 45-degree reference angle. So I know x equals pi over 4 as well as 5 pi over 4. So my answer is the integral from pi over 4 to 5 pi over 4 of sine of x minus cosine of x dx. And let me evaluate this. The integral of pi over 4 to 5 pi over 4 of sine of x, close my parenthesis, minus the cosine of x. And before I hit enter, let me make sure I'm in radians, which I am. There's my answer, 2.828. Remember, we always want to round our answers to 3 decimal places. And there we go. All right, keep moving. Find the area of the region between the graphs of f of x, which is 3x cubed minus x squared minus 10, and g of x, which is 2x minus x squared. Let's see. So again, f of x is a cubic, so it appears that f of x is this function here. And g of x is a quadratic, so it appears g of x is this function down here. Now if you'll notice, the top and bottom functions flip halfway through this intersection. Now, I'm assuming from the bounds that they give me that my points of intersection are -2, 0, and 2, but let's check this out. Point of intersection. 3x cubed minus x squared minus 10x equal to 2x minus x squared. I'm going to bring everything to the left. I'm going to add x, the x squareds will cancel. Minus 12x equals 0, and yep, it appears my intersection points are indeed 0, -2, and +2. So what I'm going to have here is I'm going to have two separate integrals. I'm going to have the integral from -2 to 0. Now for this first part, f is my top function. So I have 3x cubed minus x squared minus 10x. Oops. Minus my bottom function, which is 2x minus x squared. Now I'm going to add that dx plus the integral for this second region. G of x is on top. Now my bounds are 0 to +2. My top function now is 2x minus x squared plus, minus f of x, which is 3x cubed minus x squared minus 10x. All right, before putting this in my calculator, again, I'm going to clean it up a little bit to make it easier. I'm going to change the minus in between the parentheses to a plus and change all the signs. And my answer is going to be the integral from -2 to 0 of, 3x cubed, my x squareds cancel, minus 12x dx plus the integral from 0 to 2 of -3x cubed, my x squareds again cancel, plus 12x dx. Now let me write this down so I can put it in my calculator. What I've got here is the integral from -2 to 0 of 3x cubed minus 12x plus the integral from 0 to 2 of -3x cubed plus 12x. And my answer is 24. So this equals 24. All right. Next, we're going to look at horizontal rectangles, or the y-axis approach, and I'll show you why. Find the area of the region bounded by the graphs of x equals 3 minus y squared and y equals x minus 1. So I know y equals x minus 1 is obviously my linear function, and this first function is x as a function of y, so it's a horizontal or sideways parabola. So I could find the area of this green region and then separately find the area of this blue region and add them together, because the reason I would have two separate answers or two separate equations is in this first section the linear function is on top and the quadratic is on the bottom. But in the second region, the blue region, the positive part of the quadratic is on top and the negative part is on the bottom. But we have an easier way to do this. What we can do is we cannot add up all of the rectangles horizontally or in the x direction. In this case, it would be easier to add up all the rectangles vertically or in the y direction. The reason being, in this case, the quadratic is always on the top, or in this case on the right hand side, while the linear is on the bottom or on the left. So a little confusing there, but I think it's going to make sense as we go. I guess I still have to find my points of intersection. So I'm going to take my two functions and set them equal. I guess I have to do one thing first. My quadratic is x as a function of y. I've got to rewrite my second function as x as a function of y. And now I can set them equal. And again, I'm going to move everything to the right hand side and factor. Which will yield y equals 1 and y equals -2. So now what I'm going to do is I'm going to add up the areas going vertically from -2 to 1 in the y direction. So what I have here is, the area is the integral from -2 to 1. My lower bound is always my less one, and the upper bound is the greater one, of my top function, which is 3 minus y squared, minus the bottom or left function, which is y plus 1. And now I'm integrating with respect to y, not to x. So I get integral from -2 to 1. Again, cleaning this up. I get -y squared minus y plus 2. Let's see, let me write that down. Integral from -2 to 1. So I'm going to go to my calculator. Now my calculator only integrates with the x's. So we can just replace the x with a y. Integral from -2 to 1 of, instead of negative, what was it, -y squared, I'll put -x squared minus x plus 2. And there's my answer, 4.5. So my area between these two curves is 4.5. All right, a couple more here. Number 6, calculator. What is the area of the region enclosed by the graphs of y equals the square root of 4x minus x squared and y equals x over 2? So I have 4 choices there, so let me set this. Oh, I guess I need to find out which function is on top and which one is on the bottom, as well as my points of intersection. So I have the square root of 4x minus x squared, and I have x over 2. So on my calculator, I'm going to go to the graphing option. I have both of them in there already. I'm going to hit graph, and it appears my first intersection point is 0, which makes sense because it's the square root of 0 equals 0, so x equals 0. And my second intersection point, let's see how this calculator does with intersections. It's a lot easier, I think, on the TI-84. There's my left bound, there's my right bound, and there's my guess. So it appears it is 3.025. Okay, let's take a look here. Oh, and I'm sorry. My top function is the half circle, and my bottom function is the linear function. So I have the integral from 0 to 3.025 of the square root of 4x minus x squared minus x over 2 dx. All right, let's evaluate this in the calculator. The integral from 0 to 3.025 of the square root of 4x minus x squared parentheses minus x over 2. All right, I got 2.810. Let's go back, 2.810, and I don't see that answer. All right, so I have an issue here. I'm guessing my intersection point might not be exact because it's kind of weird. If you guys can try this on your regular TI-84, and we'll revisit it later. Everything looks correct. Did I put it correct in the calculator? Might have a little parenthesis error here. Oh, it's not letting me go back. So I'm going to recheck this one with a regular graphing calculator later. I think there might be an issue with the parentheses. All right, let's keep moving. Identify the definite integral that represents the area of the region bounded by these two graphs. Okay, let's see. 4 minus x, I can do this without a graphing calculator. 4 minus x squared is that parabola. Y equals x minus 2 is that. Okay, so I know the quadratic is on top, the linear is on the bottom. All I'm going to do is go ahead and find my points of intersection. And what is this? Factors of 6 that add up to 1. So 2 and 3, a plus and a minus. So that yields x equals 2 and x equals negative 3. Bad looking 3. All right, so it looks like my options are going to be A, B, or C. So it's the integral from negative 3 to 2 of my top function, which is 4 minus x squared, minus my bottom function, which is x minus 2. And what do I get here? Negative x squared. I'm going to change my minus to a plus, change all my signs. Minus x plus 6. Let's see. Looks like my answer is B. All right, I'm going to save numbers 8 and 9 for tomorrow because this is already a very long video. So yeah, I'll work out numbers 8 and 9 tomorrow, and maybe I'll revisit number 6 if I can find a regular graphing calculator or type it in differently. So that was our first part of the lesson on the area between